Our vision is to be leading sustainable solution provider to Malaysia's essential natural resources, water, mineral and energy.
ALN Dynamics Sendirian Berhad is a Johor-based company and provides a full range of services for water supply development, including collector wells, riverbank filtration systems (RBF), surface water intakes, hydrogeological investigations, water resource management, aquifer recharge well, and complete design build turnkey construction. The collector well is constructed with a reinforced concrete caisson that serves as a wet well pumping station. Horizontal well screens are installed near the bottom of the aquifer, resulting in high yield capacities that can range from 1/2 million litre per day to 20 million litres per day from a single well. Let's hear from someone who operates the company ALN Dynamics Sendirian Berhad or ADSB, who run the collector wells.
Whether you need an ocean of water, naturally filtered water, or something in between, ALN Dynamics Sendirian Berhad, also known as ADSB, can produce the supply you required from whatever source available. ADSB specializes in design and turnkey construction of high-capacity water supply system, including horizontal collector wells, surface water intakes, and riverbank filtration.
From the initial consultation and evaluation to construction, our experienced teams will create the most cost-effective and efficient system to deliver water in the quantity and quality needed. Now let's take a look at the actual construction of a collector well by ADSB. After a potential site is selected, ADSB geologists conduct a complete hydrogeological investigation. Samples of aquifer materials are obtained from the drilled boreholes. After the evaluation of the boreholes samples, a test well and the series of observation wells are drilled and constructed. During the pumping test of the test well, ADSB can observe the effects of the water table at each of the observation wells. Results of the analysis of the pumping test data will be analyzed to determine the hydraulic properties of the aquifer. A course of concrete is poured. A steel cutting shoe was constructed in the first section of the concrete caisson to assist in the sinking process. The concrete walls are reinforced with steel rebars, which are woven and tied before the concrete is poured. This process will be completed on each succeeded section of caisson. Next, the workers install concrete around the outside of the caisson to form a dead mat, which will add in the sinking of the caisson. Here we see the completed cutting shoe. As the workmen continue to tie the steel rebar, noted, we see port assemblies are already installed in this section of caisson. These port assemblies are the locations where the horizontal laterals will be projected through the caisson and into the surrounding aquifer. The outer form is positioned and the concrete is poured. This well has a 15-foot diameter and 100-foot depth. When conditions occur where larger yields are required, the diameter well will increase to accommodate larger pumps and motors. Construction continues in this manner until the top of each section of caisson reaches the ground level. At that time, the next section of caisson is constructed as the process continues. When all sections of the caisson are sunken to the required well depth, a concrete well plug or seal is placed in the bottom. After the specified measurement, the base plate is constructed. If the hydrostatic heat is great, the plug will be reinforced with steel beams and base plate. Shown here, a professional diver is assisting in the inspection at the bottom, prior to the concrete and beam placement. Divers drill holes around the caisson wall to plug in the bolt nut between base plate shoe to caisson wall. At this stage, first steel bars are now sunken in, followed by the second steel bars. After the second steel bars are sunken in, The diver will do the final check before concrete is poured. The diver shows the condition of lateral opening for holes number 1 to 6. A special pipe called a tremie pipe is positioned in the center and lowered into the well. A funnel is placed at the top of the pipe, while concrete is poured through the pipe and into the bottom of the well to create the plug or bottom seal. The next construction steps are the installation of the horizontal lateral screens. But water horizontal laterals are quite simply the water collecting wing that stretch out into the sand and gravel aquifer. As shown here, horizontal laterals greatly increase the efficiency of the groundwater abstraction as they are extended into the water-bearing aquifer in all horizontal directions. For example, laterals can be up to 100 meters in length or longer. Let's take a look at the construction of the horizontal laterals. A smaller line, called a sand line, is contained within the temporary casing. This line is connected to the cutting head and auger and is used to carry sand and gravel into the caisson. Water samples are collected and evaluated for proper screen's slot size selection. Once the temporary casing is in the proper position, the sand line is removed and the workmen begin the process of well screen installation. As this continues, larger particles of gravel are repositioned against the temporary casing, forming a natural yet permeable full-length ceramic bit around the pipe to prevent clogging. Once final lateral length is achieved, the sand line is removed and the screen is installed. The temporary casing is then removed to expose the screen, and the sand line is reinstalled to remove any remaining fine sand during the screen development process. When completed, the sand line is removed, allowing water to flow freely into the caisson. Then, a pumping test is performed to confirm projections of well yield and drawdown. The final step involves the construction of a pump house, necessary pumping equipment, and water transmission lines. Water valves are opened and the well is ready for operation. The result is a complete pumping system contained in a single unit. Shown here are sections to the temporary casing that are safely lowered into the work area below and positioned for insertion into the lateral port using a specially designed pre-packed screen. The screen pipe is placed one section at a time into the temporary casing. Each consecutive section of a pipe is secured to the one already in place. The process of adding screen pipe continues until the predetermined length is reached. Once all sections of the screen pipe are in place, workmen will begin removing the temporary casing to expose the screen to the aquifer deposits. Hydrostatic pressure forces water and sand and smaller gravel through the screen pipe and into the caisson. This process flushes the lateral up settlement. High-pressure water jetting is also utilized in the screen development process and is shown by the blue pressure hose. This jetting agitates the smaller sand and gravel around the screen and flashes the lateral up settlement. Contact ALN Dynamics Sendirian Berhad today for a confidential review of your specific water supply and needs. You can also log in to www.alndynamic.com. ALN Dynamics Sendirian Berhad, ADSB, is proud to provide environmentally safe solutions to meet Malaysia's demand for water supply development.